Every day, whether you are using Google Maps to find the fastest route, scrolling through your social media feed, or even searching for products on your favorite e-commerce site, something amazing is happening behind the scene. Complex data is being processed and optimized in milliseconds. But how does it happen? The answer lies in data structures and algorithms, often called DSA. Let's break it down. A data structure is simply a way of organizing and storing data so it can be accessed and modified efficiently. Think of it like a family tree. When you want to store information about your family and how each person is related, a family tree makes it easy to visualize who is who. With this tree, you can quickly trace relationships like finding out who's your mother's father's sister is without needing to sift through all the individual data. Similarly, in programming, data structures help us organize and manage large amount of data in ways that are intuitive and efficient. Now, let's talk about algorithms. An algorithm is like a recipe, a set of instructions to solve a specific problem. Take a cooking recipe for instance. First you gather all the ingredients and then follow the steps to make the meal. In the world of computers, an algorithm is a series of instructions written in a programming language that operates on data structures to achieve a goal. So whether it's finding the fastest route in a GPS system, searching for users on a social media network, or sorting movie titles by rating, algorithms guide us in how to efficiently process and retrieve data. Here's where things get exciting. Data structures and algorithm go hand in hand. Think of a data structure as a container for your data and an algorithm as the method you use to work with the data. Without the right algorithm, even the best organized data structure will not perform well. And without the proper data structure, an algorithm may not even have the right tools to operate. Together they form the foundation of efficient problem solving in programming. Mastering DSA is critical for any software engineer. Why? When you work at big tech companies like Google or you are managing large database systems, DSA skills are essential. These are the same skills companies test during their technical interviews and rely on to build scalable applications. So the plan is this course will take you on a journey through the world of DSA, from basic concepts to advanced algorithms. You'll start with asymptotic notation and searching and sorting techniques such as big B, big theta and big omega. These are the key tools we use to evaluate the efficiency of algorithms, because writing the functional code is one thing, but writing efficient and scalable code is what sets you apart. Then you will move on to mastering complex data structures like stacks, trees and graphs. By the end of this course, you will build an urban traffic management system, a project that will showcase everything you've learned. We believe that learning is best done by building. That's why throughout the course, you will work on multiple projects. As I said, by the end, you will build an urban traffic management system. This project will allow you to apply the algorithms and data structures to a real-world scenario. Imagine managing complex traffic system in a city like Bangalore, optimizing routes and preventing bottlenecks all through code. But that's not all. Along the way, you will complete several module-level mini projects that reinforce the key concepts you are learning. These projects will provide you with ample opportunities to practice and apply your skills, setting you up for success in both your coursework and your real-world development. Now, let's take a look at what you'll cover in this course. In Module 1, you will dive into the basics: arrays, strings, and various searching and sorting algorithms, including bubble sort, merge sort, and quick sort. You will also explore the key concepts like asymptotic notation and algorithmic efficiency. In Module 2, you will move on to more complex data structures like stacks, queues, linked lists, and trees. Understanding these structures will enable you to store, organize, and manage data in your applications. In Module 3, we'll get into advanced topics. You will also learn graph traversal techniques like BFS and DFS, essential for path finding and optimizing in real-world systems. Each module is designed to build upon the last, so you are not just learning isolated concepts, you are creating a solid foundation. As you progress, you will be able to see the real-world application of everything you learn, from searching algorithm to graph traversals. DSA is crucial for anyone aiming to succeed in technical interviews and optimize code in industrial scenarios. Keep in mind that companies like Google, Amazon, and Facebook rely heavily on algorithmic thinking and data structure expertise in their development teams. Are you ready to master the skills that will take your development career to the next level? With our DSA course, you will gain the expertise you need to succeed, backed by hands-on projects and mentor-based learning. Let's get started and dive into the realm of algorithms, data structures, and solid problem solving. Good luck.